Uh, Good morning, all. In today's session, we are going to discuss the brief classification or types of the polymerization. Before starting this types of polymerization, just I will take a review of previous session. In previous session, we have discussed the additives in the plastics. Then what is the meaning of additives, and what is their effect when they are added in the plastics? These are some common effects. Then after that, we have discussed some commonly used additives for the plastic material, like plasticizer. Suppose if you want to improve its flow characteristics and decrease the brittleness, then we are using plasticizers. Then if suppose we want to reduce the cost of the plastic material, then we are using the fillers. Then suppose we want to reduce the flammability of the plastic material, then we are using the flame retardants, then reinforcing agents to increase the strength. Then stabilizers we are using to stabilize the properties of the plastic material, so that same properties will be there for longer duration of time. Then softeners or extenders, these are used to make material or plastic material soft and to improve its flowability. Then colorants are there. Different types of colorants are that we are using, like dyes and pigments. Dyes will provide you transparent colors and pigments will provide you opaque colors. Means light cannot pass through these colors. And lubricants also we are using to reduce the friction. Okay, to reduce the friction during the processing of that plastic material, and also to provide better flow. Okay, along with few examples, we have discussed these additives. Then after this, we have discussed the concept of monomer. Before understanding the polymerization process, we have discussed this: what is the meaning of a monomer, then what is the meaning of polymer. Okay, what is the meaning of monomer? Single unit or molecule from which that particular plastic material is formed. Okay, like you can compare it with the your unit cell in the metallurgy. Okay, means it is a repeating unit. From that repeating unit, that material is formed. That is the monomer. And when number of monomers came together, they will form a chain. Or when number of monomers are stitched together, the result will be polymer. Okay. For example, I told you the example of wall. Okay, you can see this wall, construction of the wall. Whichever bricks are there, brick is the smallest unit and it is repeated. Okay, that brick will be monomer. And when number of bricks are stitched together, whichever wall is formed, that is your polymer. Okay. Now, after this, and the formation, whichever process is there, formation of polymer using the monomers, this process is termed as polymerization. Okay, formation of polymers by stitching the monomers, this process will be considered as a polymerization. Now, this polymerization process is classified. I have added this chart. Okay, this now up to this we have discussed in yesterday's session, and also I think I have completed the steps in the addition polymerization. Okay, this part I have completed, but I will repeat it again. Okay, we will start with this in today's session. We will try to finish this types of polymerization. Okay, all types we will cover in today's session. So this is the chart, you can say, the brief classification of the polymerization processes for the plastic materials. Okay. Now, these polymerization processes are classified in two types. You can see here, basically two types are there: addition polymerization and condensation polymerization. And this addition polymerization is again classified in three types. Okay, homopolymerization, copolymerization, and Kraft polymerization. Then this copolymerization is further divided in 3 types. Okay, as random copolymerization, alternating copolymerization, and block copolymerization. Okay, why these names are given, that we will discuss. Okay, just remember this. I will discuss one by one. First, we will start with this addition polymerization. Okay, this is the summary. Means in short, you can. This is the brief classification. Okay, this is expected answer. You can write if types are asked. This is the summary. Okay, here I have just provided you the list. Okay, don't write this. All types are added here. Okay, addition, condensation, and this one is you can say the spatial type. You can treat this coordination polymerization as the spatial type. Okay, this is the brief classification. Now we will discuss addition polymerization first. Already I have discussed in the previous session. Okay, this is the addition polymerization. Monomers are added or stitched together without formation of any other product. Okay, no other product is formed. Now, in this addition polymerization, and if you compare this with condensation polymerization, what is the basic difference? In condensation polymerization, monomers are stitched together, but some byproducts are formed. Like here it is mentioned water. Byproduct like water may be formed. Sometimes suppose acid, any kind of acid, hydrochloric acid, HCl may be formed, or ammonia gas may be released. Okay, means some kind of one kind of byproduct will be there at the end in the condensation. That's why this name is given, condensation. Okay, at the end some byproduct will be condensed. That's why condensation name is given. And in addition, simply we are adding, no byproduct will be there. Now, this addition polymerization, it occurs by these steps, and that steps you can highlight here. Generally, 3 steps are there, or 3 stages are there. First stage is initiation, second is propagation, and then termination. Okay, so I will explain it with the help of a diagram. The first stage is the initiation process. Now, for occurrence of this initiation process, free radical formation will occur first. Okay. Okay, just remember the names. I will explain it with other PPT. First step is initiation, then propagation and termination. Initiation means start of the process. Then propagation means it will expand, means chain will expand. And in the third step, that formation of chain will stop, means process will be concluded. Please remember this diagram. This is the dot. This it indicates free radical. Okay, initially here it is. Okay, this is CH2 double bond CH2. This is your initial compound, or this is your monomer. Okay, this is your basic monomer. I am taking one example. Suppose from addition polymerization, polyethylene material is formed. Polyethylene means you are using that carry bags. Carry bags are formed from polyethylene material, and its basic unit, that polyethylene is polymer, and ethylene or ethylene or ethene, same names are there. That is your monomer, and its chemical formula for that ethene is, this is CH2 double bond CH2. This is your monomer, and its chemical name is ethene or ethylene. Are you getting this? हा मोनोमर आहे इथिन किंवा इथायलिन, याच्यापासून आपण पॉलिमर तयार करतो, पॉलिइथायलिन किंवा पॉलिइथिन त्याचं नाव असतं. Now this is the chemical formula. Please try to remember this. CH2 here, in between these 2 carbon atoms, double bond is present. double bond is present. Now in addition polymerization, what we are doing, we are breaking this double bond. We are breaking this double bond, and this one monomer, that is CH2 double bond CH2, here this bond will get break and it will join to the another monomer. Same ethene monomer, one ethene monomer will join with the another ethene monomer. And how this stitching will occur? By breakage of that double bond. Double bond break will and they don't attach to the monomer. That's why this process is termed as addition polymerization. And to break this double bond, initiator is required. Initiator means one extra other chemical element we are adding. It does not take part in the chemical reaction, just it will break this bond. Okay, and that is shown in this diagram. Okay, here that double bond is broken. Are you able to see this? Double bond is broken, and this dot will indicate the free radical. Free radical means from this side another monomer can join. In simple word, this is the valency. This is the valency, means it has one valency. One dot means it has one valency. One atom can join from this side. And from this process will be termed as initiation. Okay, are you getting this? This is your initial ethene. Then we are adding one catalyst. It will break the double bond. Double bond is broken and formation of this free radical will occur. Okay, and this free radical will attach to the another monomer. Okay, this is the now this process will repeated again and again. Free radical will be formed. This is free radical. It will attach to the monomer. Now it will have one free radical again. It will attach to the next monomer. Like this chain formation will occur. This is the second step. That is propagation or expansion of that chain. Okay, and you can say that this is the polymer formation process. And one stage will come where we are not having any free radical. Okay, all monomers will have their valency satisfied. Then at that point, that stage, that process will be terminated, and that is our third stage, that is termination. Okay, in these three ways, the addition polymerization occurs. The same process, I will repeat it again with this example here. This is the first point. Here, this is your ethene monomers. Number of monomers I have shown here. Okay, 3 monomers you can see. This is ethene monomer. Then after adding the catalyst, these are free radicals. Double bond is broken here. Initially you can see here, double bond is there. Then we are adding catalyst. That catalyst will break the double bond, and these kind of free radicals are formed. Here you can see free radicals. And as they are having valencies here, from this side also, from this side, and you will find that they will form the chain. They will stitch together. And this is the formation of polymer. Means from this ethene monomer, polyethylene polymer is formed. So this is the addition polymerization process. Now by same process, for example, you can say, cannot write here. Writing pen is there. Yeah, we'll bring it. Okay, now this is the addition polymerization process. This I have explained this for formation of the polyethylene. In the same way, suppose you are using your PVC pipes are there, polyvinyl chloride. Its basic monomer will be vinyl chloride. Okay, vinyl chloride, and that PVC material is used for manufacturing of different pipes. Okay, I will show you that structure there. Please wait. Till then, I will complete the second part. Okay, the next type is condensation polymerization. Okay, please refer this diagram here. This is condensation polymerization. This is one example, and this is second example of condensation polymerization. And already I have explained this. From ethene, polyethylene or polyethylene is formed. Then in condensation polymerization, what happens? This is the example. This is one monomer. This is diacid monomer. Okay, this is the. Okay, please, you can draw these reactions. You have to draw the reaction. Just try to remember the basic group and draw the reaction. Please draw the diagrams. I will explain some chemicals on the board. Okay. Okay, now in condensation polymerization, what will happen here? Here, these are the monomers here, two monomers. Two different monomers are there. Two different monomers are there. And here, its basic unit is acid group COOH. You can see here COOH. From this side also COOH. And amine group. Okay, NH2. NH2 is nothing but your amine group. And here we are having two amines, this NH2 and this NH2. That's why diamine. And two acid groups, COOH. That's why it is termed as diacid. Okay, now diacid and diamine group. Now they will stitch together or they will be joined. And here in this process, this OH atom from this side, it will combine with the hydrogen and they will form the water. One byproduct is formed here. And remaining part will be attached together. And this is the formation of polymer. This is polyamide. Okay. This polyamide will be formed from diacid monomer and diamine monomer by formation of water. Are you getting this? Condensation means two different monomers will be joined and one byproduct will be formed like water. Byproduct may be different depending on the monomers. Sometimes suppose HCl may be formed, hydrochloric acid, or some ammonia gas may be released like that. Different byproducts may be there, or some alcohol group product may be formed. These byproducts will change depending on the type of monomers used. Just you have to understand here, two monomers are stitched together with formation of byproduct. That's why this process is termed as condensation polymerization. Now, for again, I have taken second example here, the diacid group and diol group. Diol means dash OH group will be there. Okay. Now here, H from this OH and this OH, they will combine together and water will be formed. And the remaining one bond will be this group. Remaining group will be attached to this monomer, and it will form this ester. Okay, this is polyester. Polyester material. Okay, so these are two examples of condensation polymerization. Polyamide. Polyamide is nothing but your nylon. In fabrics, we are using that nylon. Nowadays, in your vehicle tires also, we are adding the nylon. Nylon material is there in tire manufacturing. We are doing the using this nylon material. Then this is polyester. This is again we are using in the fabric polyester material, nylon material. And you are aware of this. Just you are not knowing that it's this little bit chemical formulas are difficult, but only one example you have to remember. Okay, to remember that, just remember the basic groups like ethene, CH2, CH2, like amine group, NH2 group is there, and for diamine, two NH2 groups, and here for acid, COOH, and diacid means two groups. Okay, and just you have to separate the water molecule and remaining bond will be created. Okay. So in this way, by this condensation polymerization method, polymers are formed, and examples of that are polyamide, like you can say nylon, and polyester, that is in some name is given, that is steriline. The steriline name you may have heard this. Steriline material or nylon material. Okay. So if you are having any doubt in this addition and condensation polymerization, please ask me. You can ask to the chat box also. If you are having any doubt is there? Okay, please note it down. Example of addition polymerization and examples of condensation polymerization. Note down the reaction. You can remember any example. I have explained two examples on board also. Okay. For that vinyl chloride, just from instead of this hydrogen, what you have to do here, Cl atom will be there. Replace one H by Cl. It will become vinyl chloride. Then for next example, that Cl will be replaced by that benzene group. Okay. Remaining process will be same. And here, don't forget to mention this N. Why N we are using? Because number of monomers. Okay, means number of monomers will be joined, and number of means that polymeric chain will be very long. If infinite number of monomers are joined, that's why we are using that N there, short, small N letter. And also you have to mention the catalyst used for this reaction. For initiation, sometimes we are adding the catalyst, and that catalyst is added in the high pressure medium, or we are using heat also. That you have to mention here. If you have completed, can I move towards next slide? Completed. Last bench. Okay. Now, next two slides, I have added some comparison points between these two basic types. Okay, addition polymerization and condensation polymerization. Okay. In two different slides, I have added that. Okay. Some points may get repeated. Okay. In addition polymerization, generally the addition polymerization involve one monomer. Okay, one monomer means ethene monomer, ethene monomer like this. And in condensation polymerization, two different monomers. Okay, like in that one example, in the formation of nylon, diacid. Okay, we have added that diacid to the diamide. Okay, two different monomers we are joining. But here, single monomer will be there. Sometimes it is not necessary that single monomer will be there. Sometimes two monomers can also be joined depending on their valency. Okay, but this is general statement. Sometimes it is possible that we are joining two different monomers without formation of any byproduct. Then it is also considered in this addition polymerization. Okay. Now, the second differentiating point, that is, this addition polymerization does not lead to loss in smaller molecules. Loss in smaller molecules means no byproduct is formed. And in condensation polymerization, loss of simple molecules will be there and some byproducts will be formed. They have mentioned whichever byproducts are formed, they have mentioned by the words loss of simple molecules. Okay, like water molecule or some acid molecule or some alcoholic compound may be formed. Now, the empirical formula, whichever polymer is formed, at the end, this polymerization process will give you formation, or it will result in the formation of polymer. From monomer, polymer will be formed, and whichever polymer is formed by the addition polymerization process, its empirical formula, in short, you can say that its chemical formula is same as that of monomer. Okay, just it is repeated. But in case of condensation polymerization, its empirical formula is different. It is completely changed because two different monomers are joined. In nylon, you can see that here formula just N is added. This CH2 is there only. If you go in the chemical structure here, this CH2 group is here as it is. Just bond structure is different. Instead of double bond, single bond is there. But as far as its chemical formula is there, it is same. But in case of this condensation polymerization, you can see here completely different empirical formula or chemical formula is there. Okay. It is becoming more complex. That is another difference. Okay. Its empirical formula is same as that of monomer, and here empirical formula is different from the constituent monomers. Constituent monomers means from that monomers it is formed. And few examples you can write here: PVC, Teflon. Okay. Then here nylon, nylon 6, nylon 66 is there. Okay, this is nylon 6 and nylon 66. Okay, double 6 is there. Then bakelite, or two examples I have taken, that is your polyamide and polyester. Polyamide is nothing but nylon 6. Okay. Then few points of comparison I have added in this slide. Some points may be repeated. Just go through it. Okay. The monomer must have at least one multiple bond. Okay. For initiating this addition polymerization, there must be a double bond. By breaking that double bond, we are starting the addition polymerization. And that in the case of this condensation, that condition is not necessary. Okay. Then some points may get repeated. This point is repeated. Means monomers, they will give the no byproduct is formed in this case. Some byproducts will be formed. Then monomeric units are decreased. What is the meaning of this? Number of monomeric units decreases steadily throughout the reaction. As suppose 10 monomers are there. When one monomer is attached to the second, they will form together, they will form one. Means resultant count will be 9 monomers. Like this. As stitching process is there. One by one monomer is attaching to the another. As this process is occurring stepwise, gradually monomer count will decrease. म्हणजे समजा 10 मोनोमर आहे, पहिले 2 अटॅच झाले, नंतर काउंट काय होईल 9 होईल, तर आणखी एक अटॅच झाल्यानंतर 8, असा काउंट ग्रॅज्युअली डिक्रीज होतं. मीन्स number of monomeric units decreases steadily, and here in this case monomer is disappearing. Why it is disappearing? Because two different monomers are combining and new monomer, or you can say that new polymer structure is formed. Okay. Then these are some means wording is difficult. That is molecular weight. Whichever molecular weight of the final polymer, it will be means you can calculate that depending on the initial monomer. But here, as two monomers we are using, you have to take in consideration of molecular weight, okay, of formed new monomer. Combination मध्ये एक नवीन मोनोमर तयार होतो. लक्षात येते का कंडेन्सेशन मध्ये काय होतं? In condensation, what will happen? Two different monomers will combine and new type structure is formed. Hence, for calculating molecular weight, you have to consider that newly formed polymer. Okay, and here you can consider the previous monomer weight directly. Okay, this point is same, higher molecular weight. Okay, examples are there. Okay, and here homo chain polymers are obtained and heterochain polymers are obtained. Okay, here also in some cases we will get the heterochain polymers, and how we are getting that I will explain in the next slide. Okay, this point is over now. Addition and condensation polymerization. Now I will come to the next classification. Okay, that is your copolymerization. Okay, copolymerization, then homo and craft polymerization. Now this addition polymerization is classified in 3 different types. Okay, homo, copolymerization, and craft polymerization. And what is the meaning of this homo polymerization? Homo polymerization means same monomer group, single monomer will be there, and it is joined. That ethyl, same examples you can use. From that ethyl, polyethyl is formed, or from that vinyl chloride, polyvinyl chloride is formed. That is your homo polymerization. Okay, means same monomer will be joined. Now in copolymerization, what will happen? In copolymerization, here 2 different monomers will be stitched together. 2 different monomers. Suppose A is one monomer and B is second monomer. Then AB polymer will be formed. That is your copolymerization. 2 different monomers will be stitched together. I will show you the diagrams for that. Okay, here you can see nylon 66. It is example of your copolymerization. Okay, means like condensation polymerization process will occur, but no byproduct will be there. 2 different monomers we are attaching, that will be termed as copolymerization. Okay, means suppose you have added 2 different monomers without formation of any byproduct, then it will be considered as copolymerization. For example, nylon 66, and it is formed from 2 monomers. Okay, adipic acid and hexamethylene diamine. Okay, this is the name, hexamethylene diamine and adipic acid. Okay, this is one monomer, this is another monomer, and they will combine together to form nylon 66. And as there is no byproduct, this addition polymerization will be considered as copolymerization. This is one type of addition polymerization only. But as we are using two different monomers, the name given is copolymerization, mixture of more than one or different monomeric samples to form the polymer. This is copolymerization. Now, depending on the structure of copolymerization, depending on the structure, this copolymerization is classified in three different types. Okay, random copolymerization, then alternating copolymerization, and block copolymerization. Okay, that I will explain it with the help of this slide. Here you can see, okay, random, alternating, and block. Okay, here A and B are two different monomers. Okay, A is one monomer, B is another monomer, and they are stitched alternatively when the bonding is occurring in alternate way, A B, then A B, A B, like this. This is alternating copolymerization. Okay, if suppose that bonding is occurring in, suppose here you can say that this bonding is in a fixed way, fixed pattern. But if that bonding is not in a fixed way or fixed pattern, okay, means like this: two A atom, molecules or monomers, then one B monomer, then again one A monomer, then two B monomers, like this. Means pattern is not fixed. Whichever bonding or stitching is occurring, that pattern is not fixed here. That's why this copolymerization is considered as a random copolymerization. Okay, this is alternating, means some pattern is there, or alternately one by one monomers are stitched together to form a chain. This will be termed as alternating copolymerization. Then if pattern is not fixed of the arrangement or stitching of that monomer, then it will be considered as a random copolymerization. And if the chains are formed in blocks, means here you can say this is two, three A monomers will be joined and it will get stitched to a block of B monomer chain. Are you getting this? This is A monomers chain, this is B monomers chain, and that chain is stitched together. Okay, you can consider this as a block and this is B block, and that two blocks are joined together. Okay, this process will be considered as block copolymerization. Are you getting this? This is copolymerization only. Why copolymerization? Two different monomers are stitched together without formation of any byproduct. This is copolymerization. And depending on the pattern of that monomer attachment, three types are there: alternating, random, and block. If they are joined in, monomers are joined in alternate way, it is alternating. Then if way is not fixed, it is random. And if blocks of that monomers are joined, blocks of monomers are joined together, then it is block copolymerization. Okay. Is it clear? You can draw this pattern. I'll wait for 1 minute here. Please draw this pattern. If you have any difficulty, please ask me. Okay, this is very important concept, polymerization. Without Wagmare or Wag. any doubt is there, you can put that in the chat box. Okay, I'll move towards next type now. Okay, these are some examples here. So polymerization, nylon 66. Okay, you can add a few more examples if you want. So here you can add examples like nitrile rubber is there, or one element PEVA. Okay, examples of this copolymerization PEVA in caps, polyethylene vinyl acetate. Okay, some complex names are there that I will add in the slides also. For copolymerization only, I will check whether I have added that. I have not added here. Okay. And now, okay, we have completed this addition, condensation, polymerization. Then the homopolymerization also completed. Copolymerization also we have discussed. Then craft polymerization. Okay, this is remaining. Copolymerization we have discussed with 3 different types. Then craft polymerization. What is the craft polymerization? I have added that one slide here. Yes, this is here the craft polymerization. Okay, from diagram itself, if you are able to remember the diagram, you can write the concept clearly. Please see diagram carefully. What is happening here? Here, 2 different monomers are stitched together. Okay, and no byproduct is formed. Means this is addition polymerization only. And now here you can see there is one chain of A monomer, monomer A. Okay, this is main polymer chain, or you can say the backbone. and B monomers chains are attached to that. Are you getting this? This is nothing but your Kraft polymerization. Okay, this is Kraft polymerization, not Kraft copolymerization. This is Kraft polymerization only. Okay. In Kraft polymerization, it is a process in which monomers are covalently bonded. Monomers are covalently bonded and polymerized at side chains. Means side chains are in simple words, there will be one main polymer chain of one monomer, and to that we are stitching the another monomer chain. Okay, a monomer chain will be there and it will act as the backbone, and small chains of B monomer are stitched to that backbone. This is termed as the Kraft polymerization. Okay, this is the Kraft polymerization. You can easily understand this. Okay, like you can say this is like our backbone of our body, you can say. Okay, and simple, it is having some nerves. That nerves are nothing but B monomer chain. Okay. So this is the Kraft polymerization process. Okay, so this is the Kraft polymerization. And what is the main use of this Kraft polymerization? Here they have mentioned that we can use more functional groups, okay, to improve the functionality of that single polymer material. We can do the Kraft polymerization on that, so that we will get the varieties of functionalities. Are you getting this? If a monomer, suppose we want to improve the properties, some properties of this a monomer, but we want that change in small amount, then we can go for this Kraft polymerization process. Okay. And last polymerization, that is not the part of syllabus, just I have added, this is coordination polymerization. Now this is not the part of your syllabus, just what you have to remember here, if they have asked in MCQs, the coordination polymerization, it is the process. Here it is hidden. Wait 1 minute, I will adjust it. Yes, the polymerization which is catalyzed by the transition metal salts. Transition metal salts here. Okay, these metal salts we are using like titanium, molybdenum, chromium, nickel. With the help of these metal salts, we are forming the polymer chain. Whichever polymer chain formation is there, it will take place by using the metal catalyst. That type of polymerization will be considered as coordination polymerization. Okay, one example is given here. Okay, this is the example. Okay, this is the monomer, and here this is the catalyst. This MT is nothing but your metal catalyst. Okay, MT means any metal from this. It may be titanium, molybdenum, chromium, or nickel. It will act as a catalyst to form this polymer. Okay, this is the formed polymer. Just what you have to remember here, whichever polymerization process is there, it will occur by taking the help of this transition metal salts. That's why this is termed as coordination polymerization. Okay, and that metal will also become the part of that polymer. Here you can see. Initially, in the addition polymerization, we are adding the catalyst, but it is not becoming the part. It is just helping to break the bond. But here in coordination, it may get added in that polymer also. That's why it is termed as coordination polymerization. Okay. So this is coordination polymerization. So in this way, we have completed this part. So I will just summarize this today's session. In today's session, we have discussed the classification of polymerization, how they are classified in two basic types, like addition polymerization and condensation polymerization. Then the addition polymerization, depending on its monomers involved in it or their stitching process, they are classified as homopolymerization, copolymerization, and Kraft polymerization. Then further, this copolymerization, depending on the monomers arrangement, they are classified as random copolymerization, alternating copolymerization, and block copolymerization. And one more extra type we have discussed, that is coordination polymerization. So in this way, in this today's session, we have completed the polymerization and its different types. Okay, please try to remember this. They may ask in the MCQs also. They may give you the example of the material, and they will ask you by which condensation, by which polymerization it is formed. Okay, they may directly give you the example, name of the polymer, and you have to identify the polymerization process, or they may give you the polymerization process and you have to identify the examples. Different options will be there, or match the pairs will be there. Match the pairs means on right side they will give addition polymerization, condensation polymerization, coordination polymerization, and on right side or remaining side they will give the examples. Just you have to match the correct pair. Okay, or sometimes they may not go that much detail. They can give chemical reaction and they may ask you the final polymer. Okay, means what will be their question? Okay, here they will put the question mark instead of writing this polymer. Question mark will be there, or they will give you this, and question mark will be there. This kind of questions may be there in competitive examination. Means this is the whole reaction, and they will put question mark at any one point. Either they will put question mark here, or they will put question mark here, or at this side, or here also at the byproduct side. Means these type of questions will be there in competitive examination. Okay. Okay, those who are attending through online mode, please put your roll number in the chat box for attendance. I will collect it. And after putting your roll number in the chat box, you can leave the session. Today's lecture is finished. Okay, from next session, we will start the application part. Applications of the plastic material, applications and testing of the plastic material. Okay, thank you for attending this session. You can leave now. Thank you. Okay, your roll numbers. 18, 29, 46, 67. Next. 52. Next. 30. 20 or 30. Okay, next. 20, 32. Okay. Next. 1. 1, 6. 1, 4. 61. 51. Next. 42, 70. Okay, you can leave. You can leave now.